We have some figures here. This is figure 1, this is 2, this is 3, and this is 4. So in these figures, you have to look at them. You have to look at them and you have to tell whether they are symmetric or not. And if they are symmetric, then what is the line of symmetry, or at what line they are symmetric? So look at this figure and let me tell you one thing. If you're not, if you say that, hey, it's not a proper curve, right? It's not a proper curve. Then I'll say yes, because I've drawn it with my, rough hands. So I'm sorry for that, but you just assume that it's a, very accurate curve. Assume it. And if you look at this figure, it's somewhat a glass or whatever, then you can say that yes, it is symmetric. And how? So if we draw a line of symmetry or a mirror line, so if we draw it from here, okay, so if this is a line of symmetry, if this is a line of symmetry or the mirror line of this figure, then if we place a mirror on this line and if we try to look this left side of this division of this figure, if you try to look this left side into the mirror, then the image that will be formed in the mirror will be exactly similar to what we have this on the right side of this figure. And if you look at this right side into the mirror, then the mirror image formed will be exactly similar to what we have towards the left side. Therefore, this figure is symmetric. And what is a line of symmetry? This is a line of symmetry. Can we have some other line of symmetry in this? So think, pause and think. Can we have? The answer is no. If you draw a line from here, then of course here you have curves, but here you have a straight line. If you draw it from here, then again here you have an angle, but here you have some curves. So there is only one line of symmetry possible in this figure. Okay, again, this you have to assume that it's a proper curvature. And if we look at this figure, then you will say that, hey, yes, even this is symmetric figure. And if we have to draw a line of symmetry, then that will be very simple. If you draw it from here, so if this is a line L, then this will be line of symmetry or mirror line. And why? Because if we place a mirror on this line, on the mirror line or the line of symmetry or the axis of symmetry of this figure, then if we try to look this, the upward portion of this figure, then the image that will be formed will exactly be similar to this one. And if you look this downward portion of this figure, then the image that will be formed will be exactly to this, upside portion of this figure. Therefore, yes, this figure is symmetric and this is the line of symmetry. Can we have some other line of symmetry around which this figure will be symmetric? The answer is no, because we have a curvature here and we have a straight line on this side. So there is only one possibility that we can have a line of symmetry. What about this figure? Can we have some, is this figure symmetric? So look properly, look at this figure properly and tell whether this figure can be symmetric or not. Well, the answer is absolutely no. Well, why? In this side, we have a straight, we have a line segment. Here also we have a line segment, but it's smaller than this one. And this is a horizontal line segment. Here we have a angular, two line segments are at a certain angle, right? And they are not at 90 degrees. So if you try to divide this figure into two halves such that both the equal halves are mirror image of each other, then that's not possible. You cannot. If you draw it from here, then you can look different portion on this side and different portion on this side. If you draw here, different portion on this side, different portion on this side. This is the last figure. What about this figure? Is this symmetric? So the answer is yes. If we have to draw, then if we draw a line of symmetry, from here, this will be a line of symmetry. Let's name it L1. And why I'm naming it L1? First of all, if you look at this figure, then this will be called a regular hexagon. So this figure is actually a regular hexagon. Means all the sides are equal and all the internal angles are equal. Now, why am I naming it L1? This is a line of symmetry, and around this line of symmetry, if you look this portion, then if you place a mirror on this line, then the image that will be formed into the mirror will be exactly similar to what we have on this right side. Okay, so this is L1. Now, if I say that we'll have more than one lines of symmetry in this case, then let me explain you how. If this is L1, then this will be L2. Okay, this will be L2. And if you're wondering how, then just forget about this line of symmetry, focus on this one. Then you will find that you have this one equal portion and you have this one another equal portion. And if you try to fold this portion and this portion, there will simply all the vertices, this vertex to this vertex, this vertex to this vertex, and this vertex to this vertex will simply overlap with each other. If you try to fold this side and this side, that is, they are perfectly mirror images of each other. Therefore, this is another line of symmetry. In a similar fashion, we can say that even this will be a line of symmetry, and it all will pass from a single point, that is this point. Okay, on this point, it has to pass from here. So this is another line of symmetry called, it will be called L3. And if you are wondering why, then what we just discussed in this case, similar discussion, similar concept will be for this one also. So we have L3 here. Okay, wait, we have more lines of symmetry in this case. How? Okay, so till now we have L1, L2 and L3. And so if I just remove all this, let me remove all this, okay, so that just keep in mind that we have now, till now we have gotten 3 lines of symmetry, right? Okay, so I've removed all the previous lines of symmetry, and till now we have 3 lines of symmetry, that is L1, L2 and L3. Now look at this figure properly. If I draw a line, from this one. If you concentrate on this L4 and if you try to look this side and this side, and if you imagine that if you are folding this side and this side around this line, on this folding line, then this vertex will and this vertex will overlap with each other. This vertex will overlap with this one, and okay, so these two vertices will overlap with one another. That is, they will perfectly fold on to one another. Therefore, these two sides are mirror images of each other. Therefore, we'll have L4 also. Now, if I say that similarly, if we try to draw like this, so we have this L5, right? So whatever we have discussed here in this case, same discussion will be for this one also. So we have L5 also, and similarly we can say that we'll have for this one also. So this is L6, same discussion what we did in this case and in this case, L6 also. So how many total number of lines of symmetry we have in this case? We have 6. And if I have to draw the previous one also, let me quickly draw them. This one, this was L1, that's here, and then we have this L2, here, and we have this L3, that is here, right? So total 6 lines of symmetry in this case, and yes, this is also symmetric, and it's symmetric around these 6 lines of symmetry.